Fine-tuning a giant model usually takes a whole rack of GPUs. This paper does it on one. If you like AI explained by hand, follow Papers by Hand. How do you fine-tune a 65 billion parameter model on a single GPU? You freeze it in 4 bits. Here's the radical move, and it's deceptively simple to say. QLoRA froze the base model, but it still stored that base in 16 bits. So a 65 billion model still eats 130 gigabytes of memory, just sitting there frozen. QLoRA asks the obvious question. If we're never going to update those base weights anyway, why store them at full precision? So it quantizes the entire frozen base model down to 4 bits, cutting that 130 gigabytes to about 33, and then trains the 16-bit LoRa adapters on top of it. Gradients flow backward through the frozen 4-bit weights into the little adapters. The base is 4-bit storage. The adapters and the actual computation stay 16-bit. Simple to state, but making it truly lossless takes 3 genuinely clever tricks. Let's put the whole method back together. Start with a giant pre-trained model. Quantize its frozen weights to 4-bit normal float, a data type shaped like the bell curve the weights actually follow, so every one of the 4 bits goes where it counts. Double quantize the scaling constants to claw back a few more gigabytes. Add small LoRa adapters on every linear layer, not just 2, and train only those. During each matrix multiply, dequantize the 4-bit base up to 16-bit just for that instant, then throw it away. And wrap the optimizer in paging, so memory spikes get absorbed by CPU RAM instead of crashing the run. The result, 65 billion parameters, fine-tuned on one GPU, at full 16-bit quality. That, end-to-end, is QLoRA.